Question 3D, part 2. And it says the number of people N suffering from a different virus also increases exponentially at the same, or at a constant rate of R each week. And 2,500 people were initially diagnosed. After 10 weeks, the number of people suffering has increased to 4,200. Find R, assuming the model in part 1 still applies. Now, the model we had was this one here. So N is equal to, so I've got N is equal to N0 times, and we had, well, this time we've got to find R, so I don't know, no point putting R in here as a number, and we've got a T. So let's populate this with what we can. So we know the initial number was 2,500. The interest rate, the rate of increase we do not know, but we do know it was over 10 weeks. And we do know that the number we get to is now 4,250. So we just need to make R the subject. That's really all it's saying. So let's go ahead and do that. So I'm going to divide both sides by 2,500. So that means R to the power of 10 is equal to, and I got 4,250. What is it? 4,250 divided by 2,500. That equals 1.7. All right, so all we've got to do is undo a power of 10. To do that, I just put that to the power of its reciprocal, power of a tenth. But I have to do the same, of course, to both sides. There it is. 10 to the power of 1/10 leaves me with an R. 1.7 to the power of a tenth. Here it is, 1.7 to the power of 1/10. I wish it would be in focus, though. Oh, that's better. Is 1.054495. I'll just write that in. So we've got 1.054496, I'm going to call it. Okay, because we can just keep on going forever. Now, what does that actually mean? Therefore, we should say increase equals, and this is going to be 5.449. I'm going to call that 0.5. Otherwise, we're going to have to, because if we do it to the 9, we have to round the 9 up. That becomes a 9, 10. This becomes a 5, and so on. So let's just call it 0.545% weekly, per week. And that would be how we would express our answer. Hopefully that makes sense.